Okay, so today we're going to start looking at a little bit more in detail about patterns, right? And introduce some algebra terms for you as well. So when we write down the letter X and stuff like that, we call that a variable. Okay? Variable is a letter. We use X quite often. Could be any letter, right? And it stands for an unknown quantity. We just don't know what that value is. Or that value could change. So variable is the sort of extension for the word varies. So it can take on multiple values. All right? Right, so under the splat, we wrote on X, because X is in the number of dots we don't know at the beginning underneath each of those splats. All right, so some terms to help you get used to some of the terminology in math here. So an expression, okay, is any single number. So when I say number, it could be something like the number 3, or variable. So that could be X, or say Y, or Z, or whatever. Or a combination of any of our arithmetic operations. So we could go 3 plus X. Right? So an expression is anything mathematical you see that. It could be a number, it could be a letter, it could be a number plus a letter. What it isn't, it does not have an equal sign. Okay? So if you see an expression or a math statement with an equal sign, it's no longer an expression, it's what we call an equation. Okay? So an expression is without an equal sign. So here's some examples of all expressions down here, right? I'm not going to test you on that and quiz you on it, but we use those vocabularies quite a bit in math, right? So you should be aware of it. Now, so this whole chapter is about learning about linear relationships, so the things that fall on a line. And there are 5 ways that we can represent a linear relationship. First one is using a table of values, like we have here. Now, just because numbers are in a table does not necessarily make them linear, right? Because if you want to check if something is linear, it has to be going up by an even amount. So if I give you a question and say, hey, is this linear data? You just check the spacing. Oh, well, between here and here, we're going up by 100. Here and here, we're going between 100 and 200, we went up by 100, and we went up by 100 between these two values. So the X is going up by an even amount. Is the Y going up by an even amount? Well, this went up by 200. This from 200 to 400, it went up by 200. So it's growing the same amount for each step. So this tells us it's linear. If it was not even, then it would not be linear. Okay, and we'll look into some more examples of that. Right? Now, we can describe linear relationships with words. That's sort of what we were doing last day, part of our 3 steps. So to describe this, we could say for the grams, so for every 100 grams, it costs 200 cents. So the X is growing by 100, the Y's are growing by 200. So for every 100 grams, the cost increases by 200 cents. Right? So this is like step 3 of that statement that we were doing yesterday. Right? Now, ordered paired are just another way of saying coordinates. So you can list all of our table values as X's and Y's as well. All right? And the hardest is probably coming up with an expression. This is probably the hardest. How do we come up with an expression that relates the two things? So if I give you this relationship here and say, hey, can you tell me what the relationship is an expression? Like, how do If I gave you mass and asked you to calculate cost, what would you do? What equation would you come up with? What expression would you come up with? If I gave you, if I said, hey, how much would 400 grams cost? What would your answer be? How could you calculate that other than just following a pattern? Like what calculation could you do? What pattern do you see going this way?
Dividing by
Gordon?
Timesing by 2.
yeah.
Timesing by 2. To go from here to here, we times by 2. So we can say that the expression is the cost now is 2 times the mass. All right? Okay. And the final thing that we can do is create a graph and view the picture of our data. All right, so we're going to create a graph here. All right, and to create a graph, first thing we need to do is decide on what goes on the x-axis, what goes on the y-axis. It's not really an opinion. It doesn't matter. There is some rules to follow. So what goes on what axis in this question? What goes on the x-axis? Is it mass or is it cost? How do we know?
Would it be mass?
It would be mass. And how do you know that, Lachlan?
Because it's on the top.
Yeah.
And
So
if
we
you put that sideways, it
Yeah.
would be on the
So
right.
if we're looking at our table, x comes before y. That's from the last day. And if it was written the other way, x before y, alphabetical order, right? So looking at our table, our x-axis is going to be mass. So I'll write down mass here inside of grams, right? And that means on the y-axis, we have cost, and our units here are cents. Okay? So once we've decided what goes on what axis, we need to determine our spacing so we can plot our data. So we count how many boxes do we have. On the x-axis, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right? And we need to go all the way up to 300. All right? So I'm thinking if I go every 4 lines, I do 100. That makes it nice even counting for me. It's 25, 50, 75, 100, and it helps space things up. So now to keep your graph, your table, so not from getting messy, you don't need to write down every single number. I can go, okay, this is 25, this is 50, this is 75, this is 100. Write down the major ones. You don't need to write down every single minor one because it gets really messy. Then it becomes even harder to read. Right? Then I go, okay, 125, 150, 175, 200. Right? And go 225, 250, 275, 300. And 325, 350, 375, 400. Or data only went up to 300. I didn't need to go that far. Right? Now, if you decided to go up by 20s or by 10s and everything fit on the graph, I'd be fine with that. You don't have to do the same spacing as me, as long as it's not a tiny little graph. Right? So on the y-axis, we're got to go up to 600, and I think we've got another 20 or so there. So I'm going to go, let's see, let's do every line as 50 here.
Wait, how many do we need? 400?
We need to go up to 600 on the y-axis.
Okay.
Right? With the cost. So let's do every line as 50. So we'll go 50, 100 as the second line. 150, 200, 350, 250, 300. Right? So we just need to be able to fit these in. We got 400, 500, and 600. You could actually probably space those out a bit more. Right?
Wait, so So 50 for each one.
50 for each one, all right? And we could have spaced this out a bit more. Right. Okay, so next is we plot our data points. So we go, first one is at 0 and 0, so that would be a dot right here. Then we got 100 and 200, so we go start at the 100x up to 200. And you go 200 and 400. And we have 300 and 600. Okay. Then we grab a ruler and we make our axes nice and connect a dot here. All right. So I'm gonna go like this. Ruler. All right.
Where do we want the points?
Well, connect your lines to your points right there. All right. So this assignment's got quite a few graphs in it. We're not going to do it all just for the sake of time here today. It's the 5-year-old cut into it. Okay, so I'll give you a second or so to draw your lines. Now, while you're doing that, this graph is missing one thing. Can you tell me what one thing I didn't put on this graph? Yes, a title. We need to give it a title. So we can say the cost in grams will be a title. We don't know what we're buying here. This is the cost in grams. Okay. All right. So the point of this lesson is to start looking for patterns. We're going to look in patterns to how does the x value increase, how does the y value increase, and how do x and y relate to each other. Okay, so going over to first example here. First question is, what is the difference value in A's? So remember, this is like the x column and the y column. So for the A's, what is the difference value? When it's saying that, how is it changing from the first point to the second point to the third point? Yes, Lachlan.
It's just going up by 1.
We're going up by 1. We go like this one, that's 1. There, that's 1. And that's consistent all the way through. So easy mark there, right? Now, so write down either add 1 or you can say increases by 1 or something to that, right? Please tell me how it's changing, right? Then the second question is, hey, how are the B values changing as we compare?
They're going up in multiples of 3.
Yeah, we're adding 3. 3, 3, 3. So we can say add 3 or increases by 3. Right? And the third question now is, hey, what's the relationship between A and B? To go from A to B, what do you have to do?
Divide by 3.
No, to go A to B.
Oh, 8 times by 3.
Times by 3. So to go from this column to this column, you have to times by 3 to each one of these, right? So describe that in words. If you multiply A by 3, you get B. Right? So now the next one is writing an expression. So you want to use the numbers and letters to represent what we just did in a mathematical statement. You can say 3 times A, 3A is B. Right? Now, if you wanted to add the question asked for an equation, which we don't really do in grade 8, you just change the word is to an equal sign. So it'll be 3a is equal to b, right?
Wait, but how do we like? Never mind.
Yeah. All right. Okay, so let's skip graphing this, because I think you guys should be fairly okay with graphing. Let's go to the next page here. Okay. So we got table 1 and table 2, and we're asking the same questions for each one. So I'm going to just put a little line in between here. Right, and on the left side we'll talk about table 1, on the right side we'll talk about table 2 for each one of these questions. Okay, and I'll try to color code this. Okay, so the first question goes, what is the pattern of values for the first variable in table 1? And we'll talk about table 2. So first variable is this one. So how is it changing?
By 2, like it's adding 2.
Yep, x add 2. Okay, I'm going to change colors here, and I'll go to the other one. Okay, how about table 2? How is the first variable? How's m happening? What's happening with m? What do you think, Mohammed? How's m changing? Add 1. M add 1. Okay. Next one. Okay, what's the difference in the second variable? So going from here, what do we got, Alana? So what's happening to the y between each one? So between 3 and 7, what does it change by?
4.
7 and 4, 7 and 11? There's another 4. Right, and 11 plus 15 is 4. So y add 4. Okay. Let's look at n. Between the first 2 points, what does it change by?
4 and 3.
3. How does it change by the second 2 points?
3.
How does it change by the last 2 points?
4.
1. Right? So since it's not consistent, we can't say n add 1 or n subtract 1. We just have to say n varies, because it is not consistent. Right? Now, the next step is to just graph this to determine which one is linear. Right? Could you tell me right now which one is linear and which one isn't?
Table 1.
Table 1. Why is that, Lachlan?
Because it's consistent throughout the whole.
It's consistent through the whole thing. X is consistent, Y is consistent, and table 2 isn't. So now if we graph this, you should see that. You see that one makes a line, the other one won't. All right? So we set up our table. So we got our X here on the first graph. And we have our Y, X and our Y's. Right? X goes here and Y goes here. Right? So for the X, just to speed things along, we'll say every single second line, every line represents 1. So I don't need to write that each number down, just for keeping our graph clean. So 2, 4, 6, 8, and just keeps on going. And in the Y direction, we'll see each line equals 2. So every second line, I'm going to write down 4. 2, 4, 6, 8, 10, 12, 14, 16. Right? And that will fit all of our data on. So next is we just graph this. Right? Get used to plotting your points. Right? And I'll set up the grid for that while you guys, for the next one, while you guys do that. So on the first graph, when you're graphing these, just the way we did our scales, our dots do not line up perfectly on crosshairs, and that's fine, right? So you go 2 and 3, it ends up right here, and that's fine, right? And we have 4 and 7, that'll be right here, halfway in between, right? That's fine. It does not have to line up perfectly on crosshairs. It's nice if it does. 6 and 11. And 8 and 15. 12, 15. Right there. And so far, this looks like everything falls on a straight line, right? So if you got that, that's looking good. Now for the second graph, for the spacings I did, and now you don't have to pick the same spacing as I did. I did on the x-axis, the m values. I said every second line is 1, just to make it bigger. And so it goes 1, 1.5, 2, 2.5, 3, right? And on the n-axis, I did each line worth 1. So 1, 2, 3, 4, 5, 6, 7, 8. Right? Then we plot those points. Right.
How many? Okay.
There's 4 points.
Wait, I thought you said every single one was 1. Oh.
On the y-axis, right?
On the y.
Yeah.
But wait. Oh, okay. You just
Yeah.
did it. Okay. Never mind.
Okay. All right. So if we graph this, the first one's at 1 and 1. That would be a dot right there. Second one's at 2 and 4. So we start at the 2 all the way up to the 4. The third one is at 3 and 7. So start at 3 all the way up to the 7. And the fourth one, or no, it goes 4 and 8. 4 and 8. Right? Now if you look at this point here is off a little bit, right? It doesn't fall on the line. If you do a straight line here between these points, if I grab a little, it would not. Oh,
What's
oops.
the last one, Mr. Delago?
4 and 8.
Okay.
All right. Draw. All right. So if I try to draw a line here, there's no way I can get all the dots on a single line. So we say that one is not linear, right? Okay. That makes sense? And that's the whole crux of this lesson, is just look at the pattern, see if it grows. If in a table, see if the pattern grows evenly, and in a graph, it's easy. The picture tells you. All right, so let's just do one more question. All right, I want you to do example 2, and tell me, you got 2 tables here. One of these is linear, one of these isn't. Which one is linear? Compare how it grows in each variable. All right, so I'll give you a minute to compare. Yeah? Okay, let's look at this.
Because the first one I know isn't linear.
Okay, so the first one for the S,
That is
1, that is 1, that is 1, that is 1. Okay? This, what is this?
4.
4,
And then that'd have to be 6.
that's 6. What's this?
4.
4,
6.
6.
Wait, so is it linear?
So that wouldn't be linear. There's a repeating pattern happening,
Okay.
but for it to be linear, the gaps need to be the same, right? So this one's not linear. Even though there is a repeating pattern. You can draw this out and you'd see that. Okay? The next one. Okay, going from here to here, what happened?
-3.
-3. It doesn't always have to be positive. It can be subtracting. -3. From here to here, is it still -3?
Mm-hmm.
All right. Okay, going in this direction. How did it change? From -6 to -3.
You added 3.
You added 3. So I'm going to do a +3 just to make it look like we added 3. And going from here to here, once again, we added 3. So on the right-hand side one, there's even spacing happening everywhere, right? So this one is linear. Okay? So that's it. All right.